So we are welcome to this today's facilitation class organized by National Open University. So let's move on by from where we stopped the other time. Let me share my screen. So can you see my screen?
Yes, sir.
Okay. So with volume integral, let's just continue from there. That means we have a lot to learn. Then I will advise also, if possible, you guys can go and learn other theorem. All you need is their definition first, then we can now solve one or two questions on it so that we can move. We have volume integral. Then under it, under the volume integral, there are certain things we need to also check. Let's just go straight to the question. There is this, let's f field of f be a vector point function and volume V enclosed by a closed surface. So we have integral of, let's look at this. When they say volume is triple integral by f dv. We all know the v, what v can be. Where v is the what? Who can tell us the v? What can tell us the v?
It is the volume, sir.
Is the volume. And
yes,
our dv is equals to the s, the y,
the z.
The z. Three plane. Now let's look at the example one. Example one say if the field f is equals to 2zi minus sj plus yk given region bounded by the surfaces, then s equals to 0, y equals to 0, s equals to 2, y equals to y, z equals to x squared, and z equals to 2. So we can go ahead and work on this. So for us to work on this, what do we intend to gain from here? There are certain things we need to look into. Solution here. We have integral of what is the first integral, let's say we use x, we use z rather. That is, here I have s squared to 2. S squared to 2, upper limit minus lower limit, followed by the x. Remember, s is equals to 2 is the same thing. Remember, we have x squared, right? So we can substitute. Okay, who can tell me the second band for the second integral?
That's y.
Yes.
0 to
X. Let's say x. The second integral is x, is the x. The third integral is the y.
Okay. How is 0 to 2?
Anybody?
As 0 to 2. If it is x, if the second integral is x.
0 to 2. Where do you see 2?
We have x equals to 0 and x equals to 2.
Yes. Then that is the last one. So what will happen to the y? Okay, you mean what happened to the y? Anybody? What I'm saying is the first time we are differentiating, we are integrating the z. The second time we are integrating the x. While the third time we are integrating, the y.
Y.
Yes. So I'm listening. Nobody. Okay.
X, that will be.
So if I said 0 to 4, 0 to 2, our f, because I will still ask question, dv equals to integral of 0 to 2, integral of 0 to 4, and integral of x squared to 2. What is our f?
I'm sorry, sir. Why did we see 4?
I'm coming. That is what I asked you to do. X squared, xj, sorry. I'll tell you now. The s, the z, so my differential is the z, the x, and the y. Can you see the further? Hello?
Yes, sir. Yes, sir. Why is
Can you see the 4?
Yes,
So
sir.
now let's continue. Any question? No question. Okay. Let's integrate this. You integrate others, you fix the remaining constants. So if I'm integrating this one, 0 to 2, 0 to 4, I will integrate this one first with respect to what? Z. So I'm going to have 2z squared over 2i minus xz j plus zy k. X squared 2. The remaining will be the x dy. Are you getting it?
Yes, sir.
Okay. So now that we have this, we can go ahead and cut this one. Substitute your limit, upper limit minus lower limit. Don't forget, upper limit minus lower limit. What is my upper limit now?
2.
Your upper limit is what?
2.
2.
Yes. So it's going to be 2 squared. Let's just be substituting in 4i. Are you following me?
Yes, sir.
I will substitute it directly. 4i, okay, let me put it in bracket. 4i minus 2sj plus 2yk minus upper limit, lower limit rather, s squared I minus s cubed.
Sir, since we have z squared there and it is x, we are representing z by x squared. Is it going to be x squared?
You put s squared there. This is z. You are
I thought it was z
substituting.
squared.
You said?
We have z square I.
It should
So
be
it
s
will be
raised to
4.
power of 4,
Thank
sir.
you.
4.
Okay, thank you. Z x cubed j plus, when you substitute to this one, what do you have?
S square y.
S squared y k dy dx dy. So I can open the bracket, or I can integrate depending on what I want to do now. Do I want to solve for y or do I want to solve for z? It depends on me. You know, I can integrate directly like this. Which one do you prefer to solve first?
Let's do the y.
Let it be y. Okay. If it is, no, sorry. Our y is 0 to 4, right?
Yes, sir.
Am I right?
Yes, sir.
Okay, let's keep the x 0 to 2. Now let's solve the y. So it's going to be what? 4yi minus 2x, 2 spaces too much, 2syj plus 2y squared over 2k minus s is over 4yi minus s is over 3yj plus s squared y squared over 2k. Zero to 4 dx. So I can substitute my value easily. This cancel this. Upper limit minus lower limit. Lower limit here will be 0. So we don't need lower limit in this case. So we can go ahead, let's substitute. What's remaining? You have 4 times 4.
16.
16i minus 2 times 4.
8xj.
8sj plus 16k. Do you agree?
Yes, sir.
Yes, sir.
4 raised to, okay, this one will be 4x4i minus 4s cubed j plus
16 over 8.
16x squared over 2, which is 8, right?
8, yes, 8x squared.
8s squared k. Everything dx. I can decide to open the bracket. I can decide to keep it like that. So let's continue. The next thing is what?
Dx.
Dx. So it's going to be what? Integrate this one with respect to x. 16xi minus 8x squared over 4 over 2j plus 16xk minus
4x raised to the power 5. 4x
s raised to the power 5 over 5 minus 4s raised to the power 4
over 4.
plus
8x raised to the power 3 over 3.
So you don't need to put plus c because automatically they will cancel by the time you substitute. So what do you have now? Year 1, year 4. This one go with this. So let's substitute the value now. You have 32i. Here you have minus 4. Or should we just do it one after the other? You have 16 into 2i minus 4 into 2 raised to the power 2j plus 16 into 2k minus 4 over 5 to 5 plus 2 raised to the power 4k j plus 8 over 3
So would it be plus or minus?
no minus. This is minus. Remember, we are opening with the negative.
Yes, sir.
Negative, positive, negative. Yes, thank you. So let's substitute. This is k. We have 32i minus
16j.
16j plus
32k.
2 raised to the power 5 is what?
32.
32 times 4 divided by 5.
128 divided by 5.
Is what?
128
128.
divided by 5. Right.
2 raised to the power 4.
16.
So you can now add component by component. This plus this. What do you have?
It's going to be minus it too, not plus. We have 32i minus 128.
Yes, I know. That means 32 minus 128 divided by 5. You have it to be 32.
32 over 5. Aye.
32 over 5. I.
Minus 16j plus 16, that will be 0.
0. No. Are you sure we are doing? Let's get it right. Are we not missing anything from here? Do we get this one right?
Unless we are going to say, unless the minus is affecting the square root of x, which is
No.
2.
There's not. What? That's the square root will
Yeah.
not affect anything there.
Exactly.
No, I just want us to make sure we add it together right, in right manner. Tayo, please, guys, check it. All of you, check it together. 32
Okay, sir.
minus 64 divided by 3. That is plus 32 over 3.
Yes.
Right?
Okay. Yes, over 3k.
Yes. So I want you to check the integration, so see whether we are missing anything or not.
So since we understand the concept, sir, let's move forward. Maybe later after the class.
Yes,
Let's take
you
it
can
as
go and
assignment,
check.
sir.
So that is the major thing. So let's look at another question in these concepts.
So I have a question, sir.
Go ahead.
So what is the difference between volume integral and triple integral? Are they the same thing?
And what?
And triple integral, sir.
Triple integral, the difference between them is very simple. Triple integral, we use 3 integral, and the volume integral also we use 3 integral. But the issue is, where do we talk about volume? It depends on what the examiner is telling you. It depends the way we solve it. Triple integral might not necessarily have, it might not come in form of vector. It might not have I, J, K, all the components. It might just be, triple integral will just be, okay, integrate this thing with respect to X, Y, Z. I don't know whether you get the point.
Okay, that is triple integral is for scalar functions, sir.
Yes. That
Okay,
for
sir.
scalar, that's okay. When we are talking about scalar, it's like talking about scalar. But in this case, in the volume, you'll be talking about vector, in vector spaces, bounded and closed with particular thing, particular service. I hope it's
okay, sir. Yes, sir. Yes, sir.
So that's the difference between them. They can even give you 4, they can say you can integrate 4 times. All you need to do is just to taking them one by one. X, Y, Z, K, just be doing them one by one. Number 2, let phi equals to 45x squared y, and let V denote the closed region bounded by the plane (4x plus 2y plus z equals to 8), s is equals to 0, y equals to 0, z equals to 0. Now, for us to integrate this solution now, remember we are talking about xy's plane in this case. So we have the volume integral to be in this form. Remember, because we are given phi, so we're using phi to work on this. So now let's look at this. So let's say we have this. We have Z, Y, and our S is here. The origin is from 0. Then don't forget your Z. If we can make from here, now from the equation we're given 4x plus. First thing you need to do is to first of all resolve the limit, the bound, the regional bound, that is upper limit minus lower limit. First of all, resolve them to know what goes to what. Once you know that, it will be now easier for you to solve the problem. I hope I'm communicating now. So don't just jump to integration. Yes, you know integration. Congratulations, I know you know it. But the problem is at what bound are we working towards? So first thing is we have 4x 2y plus z equals to 8. Keeping x and y constant. You keep x and y constant and you integrate from 0. Z, we have z to be 0, right? Z is 0. That is lower limit. So what is going to happen to the upper limit? So what you do is make z here subject of formula here. So we're going to have z equals to 8 minus 4x minus 2y. So it simply means that we integrate from 0 to 8 minus 4x minus 2y. That is for z, dz. So let's try the second one. That is xy plane now. We hold x1 plane. So let's look at when we make x constant, and integrate with respect to y, that is xy plane, what happened? Now, at this point, z equals to 0. If z is equals to 0, from here, let's call this one equation 1. If z equals to 0, what happened? And it simply means we have our y, z equals to 0, we now have y equals to 0. Sorry. Y equals to 0. So 4x plus 2y equals to 8. Or we have our y equals to 4 minus 2x. Or our y will be equals to 1 minus 2x. Don't forget, it is very simple in this way, rather than to go into the other way. So we're going to integrate from 0, y equals to 0, to 4x, 4 minus 2x. So, but for the YZ plane, this is for, we are talking about the y now, right? I'm just trying to break it down so that we can all understand it. For the YZ plane, our s equals to 0 to s equals to what? Who can tell us? Hello?
2.
You said? Hello?
2.
2.
I think
How do
2,
you get
sir.
your 2?
So we make y and z to be equal to 0, sir.
0.
Yes. Y and Z equals to 0 from here. Then find your x to be 2 from equation 1. So we can go ahead. Let's look at it now. For x, we have s equals to 0 to 2. For y, we have y equals to 0 to 4 minus 2x. For z, we have z equals to 0 to 8 minus 4x minus 2y. So we can write it 45 x squared y dz dy dx. Like we did the other time, we're going to do the same thing. So do I need to solve this one, or you solve it by yourself?
We can solve it, sir.
Can you solve it by yourself, or I should go ahead?
We can solve it. We can solve it, sir.
Can solve it.
Do we all agree?
Yes, sir.
Yes, sir.
Okay. So
Sir, give us the final answer. So at the end of the day, if we
okay,
are
the
not
final
getting it,
answer will be 128. 128 will be the final answer. Yes.
okay, sir.
So,
Sir,
yes,
please, I have a question, sir.
go ahead.
In case that, like in this one now, we did that, we're given that the boundary was 4x plus 2y plus z equals to 8. Now, in a case whereby it is written an inequality form, how do we go about that? Like in a case whereby we have a question like triple integral of x squared plus y squared plus z squared, then we're given that 1 is less than or equals to x squared plus y squared plus z squared, which is less than or equals to 2. Are we going to just input this method also, sir?
You have to break the, you have to solve it number line and get the band domain. You remember from the number line. First of all, solve it in inequality to get your, which area, what's the band of my x or my y or my z domain. After you break it down, then substitute it the way we substitute now. Make one constant, make the other one, integrate another one, y plane, x plane, xy plane, zy plane.
Okay, so to get the band of z, we have to make sure we solve the inequality of the equation.
Exactly.
Before, then we put out for y, then
exactly. That is what they are testing there. It's not that any other difficult things.
Okay, sir. Thank you, sir.
Any other question? Okay, let's move forward. I can see we are on fire, right? Exam is very close. So everybody is serious now. You can lay your hands on some of those questions and make sure you just solve them. Now you have the method, but I still have it. Okay, let me just help you with this halfway, because there are some things here that we have to be careful with. 0 to 2, 0 to 4 minus 2x. Now, if I integrate this one, what do I get with respect to z, right?
45 x squared
45
yz.
X squared YZ. 0 to 8 minus 4x minus 2y. The y, the x. So I have this 0, 2, 0, 4 minus 2x. So when you substitute, what do you have? 4x 45. I can even take 45 out of it. Just put your 45 here, just to have a rest of mind. In brackets, 8 minus 4x minus 2y, right? dy dx. You can open the brackets or integrate with respect to y straight, depends on you. Then don't forget, if you don't want to make mistakes, make sure you do it this way, so that you know what each integral is stand for, so that you will not make mistake by integrating the one with z with y. Please take note of that. So I believe you should be able to solve this one now. When you integrate this one with respect to y, open the bracket, then you can substitute and get your final answer. So let's go to the Green's theorem because of our time. Like I told you, 128 is the final answer if you solve it very well. Green's theorem. For the Green's theorem, there are certain rules we need to also follow. And there is a particular question there that always comes, but by the time we get to that place, we will cross it together. But I'll just give us the major formulas that we normally use in Green's theorem. I may not necessarily state it. I think you have in your textbook, it was stated there, right?
Yes, sir.
Okay. Go and know the definitions of Green's theorem, Stokes theorem, divergence theorem. The three definitions always come. Make sure you know it. It is advisable. So when we have, in Green's theorem, we have this integral of when you have this, if two functions p s comma y and q of s comma y and their partial derivative are single values and continuous over a plane region R, bounded by a closed curve C, then integral of closed C P dx plus Q dy is equal to integral of partial Q over the x minus P over the y, divide everything multiplied by the A. Now, in this case, what is our if you said our phi of x will be what? Let's look at it. What is our P of x? Anybody? Our F, the R in this case is what? So let's look at this. Let's f of x comma y equals to p I plus q j be a vector feed. Then R of L to be what? Xi plus yj. You remember? What is our dr? Anybody? Is the xi plus the yj. So now, in this case now, I'm just trying to show us how we come across some of this method. When you now have f of the r, it simply means I have p I plus q j multiplied by the si plus the yj. The same thing we are doing so far. Our f dot dr will be equals to what? Will be equals to, you remember when you multiply
that is
I
dot
dot
product,
I is 1,
That's
right?
product. Yes, sir.
P dx plus q dy. So that is where we come across, and this is work done. They call it work done alone, a simple closed curve. When you integrate this with a simple closed curve, you have f equals to integral of closed off c by p dx plus q dy. So, and we know the definition of closed, it will be what? When you have w, work done will be integral of this equal everything equals to 0. But now let's look at the example anyway. In example, there are two things. There's this example that normally it's a bit common, but I want us to do it. Number one, I said verify. They can ask you to verify Green's theorem. I'll just write the theorem like this. In xy plane, for this close of xy plus y squared dx plus x2 dy where C is the closed curve of the region bounded by y equals to x and y equals to x squared. Don't forget the formula says what? Solution. Who can remind us the formula? Anybody?
Mm.
Yes.
Integral of c p dx plus q dy is equals to double integral.
XY. Okay. You are telling me the formula now. P dx plus Q dy equals to surface integral of the what?
The Q
The
over
q
there.
dx.
The
The
Q
Q there.
Partial derivative, yes.
dx minus the P
The
dy.
P dy.
Everything dA, right?
Yeah.
Okay. That's fine. That's fine. That's fine. So, but for us to solve this problem, let's look at this diagram. Remember, I told you your limit first. The first
Sir,
one
please
is this.
let me put down the question, sir.
Okay.
Sorry, sir, for that.
Please be writing, no, as I'm writing, be writing.
Okay, sir.
So when you have y is equals to x, y equals to x is in this plane, right? Then we have it to be this side to be 0, 0. And here we have it to be. Then the y equals to x squared will still be from the same side. In this format, it's a y, 1. So at this point, this is moved towards this side, and here is coming toward this side. Y equals to x squared. Now, it's just an illustration that will guide us. So if you look at for us to get this y equals to x, now y equals to x squared. We are talking about along y equals to x squared. Now, what happened? What is the y?
The y is equals to 2x.
The y equals to 2x dx. Do you agree?
Yes, sir.
2x dx. Now, we go into, remember, we want to prove. We are trying to verify something. That is what we are doing first. We want to verify that this formula is equals to this formula. When you solve this one, this is what you get. But when you also solve it in the other side, this is what you get. That is what we are trying to verify. So we can now substitute this into 0 to 1. From here, 0, 1. Then go to your equation. Our equation is what? X, y equals to this. So let's substitute it. So you are going to have what? X in bracket what? What is y? From here.
Y is equals to x squared.
Plus x raised to power 4.
2. Yes.
Do you agree with me?
Yes, sir.
Kausara, Samuel, are you guys there?
Yes, sir.
Just go here. Is this equation that I'm substituting into? Remember that we are working along this plane. And we need to make everything to be in form of the x. So we have it to be x squared. We need to change this one also. That's why we now differentiate that x squared, to differentiate it to be x squared. Differentiate the y equals to x squared so that we can get this form. So at the end of the day, what do we have? All we are doing now is we will first of all do this when your y is equals to y squared. We will also do when your y is equals to x. So those there are what happened to the y equals to x. It's still going to be the same thing. We're going to do the both. I'm only solving the one of y squared, x squared first. So here we have what? We have x squared. We have x squared in bracket of what? 2x dx. Do you agree now?
Yes, sir.
Okay. So 0 to 1. So what this one will be is what? X raised to power 3 plus x raised to power 4 dx plus 2x raised to power 3 dx. Any question? We can now integrate this one. When you integrate this one, what do you have? X raised to power 4 over 4 plus x raised to power 5. Or you can just open the brackets. We can open these brackets by saying
And
this.
it's 3x cubed.
Do you agree with me now? So
Yes,
this
sir.
one will be integral of 0 to 1, 3x cubed plus x raised to power 4. We can't add that one because of 4. So when you integrate this, what do you have? 3 into x raised to power 4 over 4 plus x raised to power 5 over 5, 0 to 1. If you solve this one very well, what do you have? You will have 19 over 20. Go and check it. So along y equals to x, what is the y? Is equals to the x. You agree with me?
Yes, sir.
Substitute it again. 0 to 1 into our. Then when you substitute this one into your equation again, you have it to be x into x plus x squared dx, which is the same thing as plus x squared dx, which is the same thing as integral of 0 to 1, 3x squared dx. So when you solve this one, you have 3x cubed over 3 into z. Sorry, the limit we change here, we change to 1 to 0. How do we change the limit for 1 to 0? Let's go back to this. So we look at this. Look at the way the arrow is moving here. It's coming from here to this place. Why this one is moving up? That's why we can take the 0 to 1.
Yes.
Are you
Okay.
getting the direction?
Yes, that is, the curve is going from 0 to 1, while the straight line is going from 1 to 0.
1 to 0. So please take note of that. So let's move on. So this one we have 0, 1 to 0. So we have 1 to 0. So at the end of the day, this cancels this. So when you substitute this one, you have -1. So then it requires of us to add everything together. So the line integral will come in. Then the require line integral is equals to 19 over 20 minus 1, because we have to add it together. So at the end of the day, you have it to be -1 over 20, which is the same thing That is when you solve the first one. That is the first phase of this. Xy plus y squared dx plus x squared dy equals to -1/20. Now, let's look at, that's the first phase. Let's look at the second phase, the second part of it. It says integral of this surface dq, right? Please check dq dx minus dp dy.
Yes, sir.
Do we have it?
Yes, sir.
So the a is the same thing as the x dy. So in this case, what do we have? Let's check the x, the q, and the y. The q dx first. Remember the equation. Which one stands for the q?
Q is x squared.
You said?
X squared.
Q is x squared.
That's x squared. Right?
Okay. Now, but before then, let's look at the integral, the function of their integral first, before we differentiate. So, because it's a bit tricky here, so we move from here, and this also join the way we did the other time. We look at the arrow, we look at the direction. So here we have 1, 1. Here we have 0, 0. So y equals to x squared, y equals to x. Now, in this case now, our x will move from 0 to what? To 1. So if this occur, what happened to the next value? So the other way, our y will also move from S2 to S. Are you getting the direction now? From S2 to X. Now,
Yes,
one of the things you need to be careful with is this side. So it's going to be S equals to 0 to 1, y equals to s squared to x. Now, how do we integrate the problem that we have here now? Identify your q. Your q is equals to what?
x squared.
S squared. Okay, let me write the whole equation. Give me the equation, please. Okay, yes, this is q. This is p, right?
Yes, sir.
Okay, what is q? Let's substitute it here. Should we differentiate it separately? Let's just differentiate it. The q dx. What do we have?
2x.
2x.
2x. So the p, the y, what do we have?
X plus 2y. Oh, sorry.
You are right.
I'm right actually. Right.
S plus 2y. So these are the things we are going to put here. So it's going to be, put them q, 2s minus
X plus 2y.
S minus 2y. You agree with me?
Yes, sir.
You have to be
DA.
careful.
In the private bracket.
You understand that it's a bracket. This
Yes,
minus
sir.
this, I can have s to 0 to 1 and y equals to s squared to x, which is what? This minus this, you have x minus 2y.
Minus 2y.
The x, dy. So which one I might integrate first? I can use my y. If I'm using my y, what do I have? Let me integrate y. So I'm going to have s equals to 0 to 1. Let me integrate y. What do I have? Xy minus 2
XY minus
squared over
y
2.
squared.
y squared over 2. dx.
dx.
Dx. So which means I have integral of 0 to 1. This go with this. Upper limit minus lower limit. I have x squared minus y squared. That is upper limit, right? Do you agree?
X squared minus, yes, sir.
Do you agree?
Yes, sir.
Minus upper lower limit now. Do we agree?
Yes, sir.
Some of you still processing it. Now, which kind of this mathematics this man is doing this morning?
Yes, sir.
We are doing it together now. That is why I laid the foundation for you before now. So this is what will happen. We have is 0 to 1. This one will turn to 0 automatically. You don't need to integrate it. So you have negative what?
Now,
I can write it this way that
now make it
I can say
x4
x is to power
minus
4
x3.
minus. Do you agree?
Yes, sir.
Now let's integrate this one. S raised to power 5 over 5 minus s raised to power 3 over 4 over 4. 0 to 1. If you do it correctly, you have negative 1 over 20. So what do we have here?
We have minus 1 over 20, sir. They are the same.
So we just use it to prove, to verify that. Therefore, left hand side is equal to right hand side. So, any question? But now let's look at another question. Don't run away when I give you this question. It's just simple as anything. Number 2, integral of this, they will not ask you to verify again in this case. They just want you to solve. We have the band to be y equals to C full of y equals to 4 minus x squared, y equals to 0. Now, in this case, how do we solve this one? Now, our band is quadratic, right? So the nature will be
Yes, sir.
in quadratic form, which is -2, +2. It can move from here to this place. So it's moving from here to the other side. which is our y equals to, this is y, this is x, is equals to 4 minus s squared. So how much do we get now? Remember, let's quickly identify your x. Your q, what is our q and what is our p?
P is equals to y squared plus cos x, and Q is x minus tan inverse of y.
Wait, P is this, right? Do we agree?
Yes, sir.
And this is Q.
Yes, sir.
So we can say that the P or the Q, the S is what? The Q, the S, a smart student.
1.
Correct.
Minus 1 over
The P.
1 plus x squared.
What do you say? Where do you see 1 plus
Sir,
S squared?
this is just 1, sir. That one is y.
Better. Is what? 2y.
2y.
All this cause is just to distract you. There is nothing there for them. So all you need to do now is just to use your double integral straight, which is 1 minus. What is the formula for this? Let's write the formula so that you know.
1
the q, the x,
the Q,
minus the p, the y, the a, which is the same thing as integral of 1 minus 2y. Am I right? The a.
Yes, sir.
That's what they ask you to solve. Now that I know, I can now put my limit now. When my y is equals to 0, we are talking about from 0 now. When y equals to 0, what is y? What is upper bound? So you have it to be, our s is equals to -2 to 2. Then y is equals to 0 to what?
Y
equals
minus
to 4
4
minus x squared.
4 minus x squared.
1 minus 2y dy dx. So we can solve this one. Integral of -2 to 2. Integrate this one, what do you have? With respect to y. Y minus 2y squared over 2, 0, 4 minus x squared dx. So this one cancel this. Substitute it. So you have it to be 4 minus x squared minus 4 minus s squared all squared. Am I right?
Yes, sir.
ds. So when you open the brackets, very well, what do you have? -2, 2. I should ask you to go and solve it.
We're almost through, sir. Let's finish it. We can finish it, sir. This one is very simple and straightforward, sir.
I should leave this one.
At this stage, it is straightforward now.
When you open the brackets, you have x squared minus 16 ds. So your final answer will be, if you integrate it very well, minus 352 divided by 15. That's your final answer. Go and solve it. And
Okay,
make
sir.
sure you do it. If you don't do it, you are on your own. Let's look at another question. That is just Green theorem, except when you are asked to verify. That's why you pass through all this one. The Green theorem is no more than this. Are you getting the point now?
Yes, sir.
Kausara,
Yes, sir.
somebody is tired.
No, sir.
Okay. So our C part of banded, don't worry, after this question, we'll call it a day. So identify your P. Our P is what? And our Q is here. So when you have the Q, the S. But before then, how do we solve this band? It's very simple. The one of this nature, look at the way we solved it the other time. Because of y equals to x, then y is also equals to x squared. Don't forget, in this case, s and y, 1 is here, and this point, also 1 is here. At the origin, 0. So all we need to do is just to check when s is equals to 0, what happened to the y? What happened at s is equals to 0 at this point now? S is 0 and 1, between 0 and 1, and y is between this, like I did the other time, the arrow here and the arrow here. So s is between, you have two things now. The first thing is for y equals to s squared, y equals to x. And the one of s is equals to 0, s is equals to 1.
1.
That's all. So the q dx is what? 2y. Then the p dy is what? The p dy is what?
S squared.
X square Y.
That's all. S square y there.
Sorry,
Madam, you are
sorry.
differentiating with y.
Yeah, we're differentiating, sir.
So your formula is here. You know it. The q, the s, minus the p, the y. Everything divided, multiplied by the a, which is same thing as s equals to 0, s equals to 1, y equals to s2, y equals to x. Then what do you have here? 2s minus, 2y minus s squared, dy ds. So what next? Go and solve it. When you solve it very well, you have 1/12. Any question? And I stop sharing.
No questions, sir.
Are we all there?
Yes, sir.
Okay, let me. You want to ask question?
Yes, please. Is it okay if we solve some question and send it to you, sir, on WhatsApp to see if we are correct with the solution, sir?
Why not?
Okay,
If you have
thank
the
you, sir.
time.